Right. Today I'm going to be talking about this autonomous drive regeneration. My name is Tong Stone. I work at Seagate Technology. I'm a product manager. This set of materials, obviously, there is a whole army of people helping to put it together. A lot of very nice work. I'm here just to promote a message. So if you notice, during the last few product generations, there is a very clear trend, not just on hard drives, but storage devices in general. The number of components just went way up. For hard drives, I'm talking about the number of heads and media, and for SSDs, obviously, just the number of cells. If nothing else, it's just a number of shear shells. And when you have that kind of additional components, something could happen. What might happen? On the hard drive side, it is very obvious that if you have more heads within the same drive, each of the head is representing only a smaller portion of the overall capacity of the device. And that's just pure math, very straightforward. So with more and more heads, each head is representing less capacity in percentage. And what happens with that? Well, if nothing else is changing, then if you think that let's be very honest, things break sometime, right? The probability of breaking, if that stays the same, just by the sheer fact that you have more of them in the device, the overall device will have a higher likelihood of breaking at a certain point. But the thing is, it is only one of the components that is breaking. If you, at that time, consider the whole device as a failure, you have a lot of remaining capacity to throw away if that's what you decide to do. So here I am saying, maybe there is a better way to do it. Why? Because what happens if you decide, oh, just because I have a single component within my device that is having trouble, I want to throw the whole thing away. You swap it, and then very likely in the end it goes somewhere to be crushed. Well, there are a lot of things that can be wrong with that process. For one thing, if you have a person, a human being, going there, changing the drive, that by itself could be a dangerous thing to do. A lot of people report that the data centers, when they have some kind of problems, one of the major reasons is simply human interactions. People are touching it, and that could be trouble sometimes. And we're all hearing, recently, the strong message about protecting our environment. Crushing drives could generate a lot of waste, and unnecessarily generating a lot of waste. There's got to be something we can do to, make things better. And yes, there are ways to make things better. For example, recently, Seagate announced this solution. The overall solution is called CORVAULT. And with that CORVAULT, there is a feature that is considered self-healing in the following sense. Because of the system feature that is using a drive feature to basically deal with this kind of failures, single components failures within devices, the system user will have a total, satisfactory experience without a strong loss of, there's no loss of data, obviously, but with very, very mild impact on the overall system performance. So that was a very successful case that Seagate was able to make on the system. But the overall flow is actually, from the concept standpoint, is actually simple. The device, when the device realizes that something like a component, like a head within the drive is having some issues, the drive can actually send alert to the system controller. And the system controller can decide what to do with that type of alerts. And one of the solutions, one of the steps could just be to take that particular component out of the device and put the device back into the system. After volume rebalance, the system is basically treating that as a new device and keep using it. So instead of swapping that drive out, you have now a new drive. And this is why we're calling this feature regeneration, drive regeneration. And probably most importantly, it's autonomous. It does not require human intervention. So sustainability is the big theme here. But underneath that, within the drive, what is supporting that kind of function? The feature is supported by a actually well-established and well-documented standard feature called Storage Element Depopulation. This is done in T10, T13. You can find them. You can actually use them to devise your system such that your system is not impacted by a single component failure. Within the drive, there are a lot of actions to take. I'm not going to bore you with any of that today, but to just call out that this actually is open. This is in the standard. The drive are able to support this type of function, and the system can enjoy having a better sustainability and better, less downtime, and more importantly, not having human being to go and touch the system if you don't have to. The feature command is basically remove element and truncate, and then in the other direction, it is called restore element and rebuild. Now, I don't have to tell you, but anywhere you look, it is a very, very clear trend in the industry that people are looking for ways for improving sustainability. I listed some of the publications from some of the companies that are doing work in that, and one of them even changed their name after my final submission to this OCP talk. So trend is very clear. The action is on us to actually go ahead and do it well. But beyond recovering from a situation that a component is failing within the device, beyond the recovering from that, is there anything else? And we think yes. For example, a lot of people, when they think about a new feature, they would think about the total cost of ownership. Now, total cost of ownership is a very personal thing in the sense that every time a company, when they decide to study something, to study the TCO, they're going to have their own model. And every company, even every technology within that company, the TCO model may be very different. So I'm not going to be here to tell you how to do that because I don't know. And I'm not going to say this is the correct model because, as I said, your knowledge may vary. But what we do see is that if we put a whole lot of assumptions into it, like how a model should be, you will see some benefits. How much benefit, I would encourage you to go calculate. But if you are in the current situation that every time you see a drive fail, you just take it out, put a new drive in, compared to that, you have a certain level of benefit. But if you are very worried about human intervention and you don't do that, you let the drive sit in the system for indefinitely, then you are probably going to see a lot more benefit in terms of TCO from that. And that's all the point I'm going to make here. The message is that no matter how you do it, we believe you will see some benefit. How much is up to you to calculate. All right, now, on our drive side, what do we know about this? One thing we do know is that today, when we receive failures from the field, a lot of them don't appear to be failures. That's a different story altogether. Among the true failures, when we look at them, a lot of them, over half of them, can be a good candidate to deploy this kind of feature, to remove a single head failure from the drive and keep the drive in service after this feature is used. So it's very encouraging. If nothing else, more than half of your true failures can be salvaged without any human intervention automatically to be put back into service. This is a big deal because this is a big impact on the environment and is very likely a healthy impact on your TCO. That's why I'm here to promote this type of usage. All right. Now, if I have said enough to make you interested in knowing about it, I want to let you know that this feature, since it has been into the standard for some time already, and it has been a feature that the entire industry is promoting, it's not just us. Some support has been built into the tools. For example, for Seagate, we use the C-chest. You can find that in either in the Seagate website or GitHub. There are different tools. This is just one example. And the commands from those tools are actually very simple, and simple enough for me to actually write them all down within one sheet of paper with pretty big fonts. You just go ahead and ask the drive, how is everybody? And then based on that response, you say, take that head out of my drive. And after that, you will have a new drive with less capacity. That is very clear because you just depopulated one element from the drive, but you have a new drive with the 95% or 90% of remaining capacity back online. You have a new drive in your hand at that time. And in the other direction, you could choose to repopulate that back into the drive for testing purposes maybe, but you could choose to do so. And the drive will make every effort to put the depopped heads back into the normal population. So here, I list them out for your reference in case you're interested, but do reach out to us if you truly want to get this whole feature implemented in your data center. Okay, so that's what has been done. We have success cases, and we are receiving more questions about it, and we're doing more work. At the same time, we are thinking about how to make this even better, how to make it easier for the customers to use it. And this is probably a good time to let us know what you think about it. Let the standard committee know what you think should be enhanced, should be modified in the existing ways to do things. For example, right now, after the process, we have a format operation that's basically making the whole drive initialized into a factory state. Would that be better to make that process optional? That's one thing we're thinking about. Another example is that, right now we're saying depopulate this head, and the rest of the heads, they still contain user data. If we try to maintain that data, we save that data, would that be helpful to you? Let us know. We want to make this easier to use so that it can be more used by the industry for all the reasons that we discussed. If there is ever a good time to let us know, this is it. So, call to actions. What I have said was that many, many times, over half of the times on our field returns, we can see that treating that whole device as a failure as a whole, just because one component in that device failed, that is becoming less and less prudent simply because we have a lot more heads in the drives nowadays. So it's less prudent and more costly to do that. Some things could be done to make things better. And this autonomous drive regeneration, supported by the drive with this standard feature called Storage Element Depopulation, that enables the recovery process from that type of issues of single head failure. It allows the continued usage of that device. and it prevents human intervention. It's autonomous. So this is a great way to reduce erased, to reduce the chance of human-induced operation errors in the data center, and also a direct reduction on TCO. So we promote this idea, we promote this in the industry to have a wide adoption of this feature, and we're here to support you to do so. And as I was saying just from the last slide, let us know how you think about this. Let us know how you want the industry to behave, to modify this feature, to carry it to the next stage so that extended usage can be easy, can be more readily doable. So that's my, my presentation today. It has been a collection of a lot of people to do a lot of work to make this happen, and we're going to continue on that path. This is my first time to speak at OCP, and I want to thank everybody for this great honor to do so. And with that, I'm going to ask if there are any questions.
Hey, thanks for the nice talk, right? So based on your presentation, it seems that you're saying that we can reuse the drive if you allow the capacity to go down, right?
Yes.
And we do see for the SSDs at least, right, some of the vendors, especially the ZNS specification, they do allow to have a reduced capacity of the drive over the lifetime of the drive. So I think if something from the spec side, if the SSD, customers define it, that hey, if the we can lose some of the capacity over the life of the drive, then these can be the very standard feature in the systems, right?
Thank you very much for making that point. It is indeed sometimes, people compare SSD behavior and HDD behavior. I had that in my slide, but I didn't emphasize on it. But for example, Samsung published their fail in place feature. That is kind of similar to what I'm saying here about the hard drives. But your point is extremely interesting because whether we can reserve enough so that this whole process of depopulating the head may become totally, transparent with customer. That is indeed one of the things we're thinking about. And this is one example of the things that we would like to, when I say, this is the time to let us know what you want to see. This is exactly the kind of inputs that we're looking for. If the industry really see that as a better way to do things, then obviously we as suppliers, as technology developers, will get on that kind of direction. So thank you very much for that point.
Curiosity, on your talk you've mentioned fail in place. Is there any difference in performance with the drive that has failed, been returned back to service? Could you expect to see a difference in performance for the drive after that? Or would you get the same rated performance?
Okay, thank you. So to the extent of a reformatted drive, the performance difference is well within the tolerance of typical drive-to-drive variation. That is the typical behavior of the drive. However, I have to say that this is still a relatively new effort. A lot of times with a huge number of drives going through the process, sometimes we may see something that we didn't expect. So this is the process. But because the existing implementation is such that right after the depopulation, we do a real format, the performance. To be honest with you, the real format, one of the strong benefits of that reformat operation is to get the performance back to where it's supposed to be, where like the factory state. That is one of the easiest thing to do, and also it makes the drive so ready. So that's one of the reasons that went behind into that direction.
Second part on that, sort of down the performance line, losing a head, losing an entire platter, will obviously affect capacity available. is there any spec or any information that would be published so that, like in a RAID system where you plan to potentially lose 1 or 2 drives and still operate, because you have enough failure capacity, is that information going to be published as part of the spec sheet for a drive so that you know, I have enough capacity if I fail, say, 2 heads or a platter, and I still have the available system capacity up until some failure point?
There are ways to get that information through different commands today. However, I think what you're saying is that maybe there should be a consolidated command for the user to just, get that information right away in a very straightforward command. Is that what you're trying to say? For example, you can always ask the drive for the capacity itself. So the drive would tell you how many LBAs I can support today for you. And after this depopulation process, you can ask again. So you know exactly how much capacity you are getting after this process. So existing commands can support what you want to know, but is that your desire to want to just consolidate that to make it all automatic? We can also make that into part of the tools too. It may not be part of the standard, but we can definitely make that happen in the tools.
Okay.
Yeah.
Right now, I don't know. This is a new thing for me, so
Yeah.
I don't know.
All right. Thanks.
So I got a question. Is the single head failure a canary of more failure upcoming, or is just a one-off phenomenon that you can?
Would you please repeat? Is the single head failure?
Right. Is that indication of more failures that might occur in the drive?
Excellent question. Excellent question. So, so you're asking me if we see a single head failure, does that mean the rest of the drive is in trouble? So the pie chart I showed earlier was trying to answer that exactly. We divided the drive divide the field returns into categories. And for some of them, we're seeing that the problem that is causing that head to fail is while isolated to that head and that head alone. So that is a great candidate for this kind of drive regeneration process. We do see other kind of drive failure field returns that it is also, after you study the logs and you look at the parametrics, you can definitely see that this is a problem among all heads. It is a device problem, it's not a head problem. That we do not recommend that you go through this process, because depopulating one head, is not enough to salvage that device. So yes, you can definitely divide the failure mechanism into, is this a good candidate or is this not a good candidate for this process? And right now we're seeing more than half of the returns are in the good candidate camp. But there's another point to be made with that question too, which is, what kind of work we need to do to make this process easier for the customers to know. And we're definitely doing that right now. And hopefully next time I have more to report on that. So, great question. Well, if there are no more questions, thank you again.